Lesson 20, simplification of radicals and line parallel to a given line. The first thing that we're going to talk about is simplification of radicals, and we're going to do a problem as we work through the different steps. So here's the problem. We have 3 root 50 minus 5 root 200. All right, now when we solve, the first thing that we want to do is we want to get the roots to be the same. The roots are just like variables in the fact that we cannot combine them unless they are equal. Okay, we have to have common radicals. Instead of a common denominator, or instead of like variables and combine like terms, we have to have a common root, okay, or a common radical. All right, so find a common radical. And the way that we need to do that is we need to factor each radical by primes. Right, so we're going to factor each radical by primes. We're going to go 50 and 200. Right, you can do factor trees, that's fine. If we break 50 down, we have 2 and 25. And 25 breaks down to 5 and 5. All right, we're left with prime numbers. So 50 is 2 times 5 times 5. Okay, now keep in mind, this is all square root. So the square root of 2 times the square root of 5 times the square root of 5. Right? Well, the square root of 5 times the square root of 5 is 5. And we're left with 5 root 2. All right, so we're taking out a double, that becomes on the outside, and what's left stays in the radical circle. So instead of 3 root 50, we actually have 3 times 5 root 2. Okay, we can multiply the numbers on the outside. 3 times 5 is 15 root 2. All right, so that one has been simplified, it's been broken down. We need to factor 200 by prime. We're going to go 2 and 100. Okay, keep in mind, these are all square roots. Okay, we're finding factors and square roots. Now, very quickly, before we factor 100 down to 2 and 50, and 50 down to 2 and 25, etc., the square root of 100 is 10. So, square root of 200 is equal to 10 times root 2. So, we have 5 times 10 root 2. Well, 5 times 10 is 50 root 2. All right, so we've come up with common radicals. All right, the second step would be combine, if able. All right, so if we have the same radicals, which in this case we do, we've got root 2 and root 2, we can combine. The root stays the same. The only thing we add or subtract is the numbers in front. So we have 15 minus 50, which is negative 35. So this becomes negative 35 root 2. Hopefully you have broken down radicals before, so this will be not too bad for you. All right, let's look at another example. In this next example, we have 3 root 2 times 4 root 12 times 2 root 3. In this case, we're multiplying the radicals. Now, when we multiply radicals, we multiply all the numbers out in front, and then we multiply all of the radicals. All right? So 3 times 4 times 2. Well, 3 times 4 is 12. 12 times 2 is 24. And then we multiply what's inside the radical symbol. We have the square root of 2, square root of 12, square root of 3. Now, my recommendation to you would always be to try to multiply radicals in which you can come out with a perfect square. For example, the square root of 12 times the square root of 3 is the square root of 36. Well, the square root of 36 is 6. So now we have 24 times 6. That took up care of 12 and 3. And the only thing we have left is root 2. All right, well, 24 times 6 is 144 root 2. Okay, so try to pair things up so that you end up with perfect squares. All right, I'm going to give you one more. This one I'm going to start walking you through, and then I'm going to have you finish it. We have 4 root 3 and then in parentheses, 2 root 3 minus root 6. All right, now, you follow the same steps that you would in any other math problem. Use the distributive property first. Multiply outside to each of the insides. Then see if you can find like radicals and combine like terms. All right, so go ahead and try this one on your own. If you need to, go ahead and pause the video, and we'll come back to this in just a second. Hit play when you're ready to move on. All right, the next thing that we're going to talk about is line parallel to a line. Lines are parallel if they have the same slope. Lines are parallel if they have the same slope. So same slope, parallel lines. Parallel lines have the same slope. For example, find the equation of the line that is parallel to the line 2y minus x equals 2 and passes through the points 3, negative 1. All right, we're finding the equation of a line that is parallel to this line here. All right, parallel lines have the same slope, so we need to find the slope of this line that's been given to us. In order to find the slope, we need to set it up according to our equation y equals mx plus b, because that is the equation of the line. All right, so we're going to add x to both sides. 2y equals x plus 2, and then we're going to divide by 2. So y equals 1/2 x plus 1. So the slope of this line is 1/2. So this line is going to be parallel because it's going to have also a slope of 1/2. So in our new line, we know that the slope is going to be 1/2. We just want to find the equation of the line. In order to finish that, we need to find b. Now we know that the line passes through 3, negative 1. So we're going to use those points, and we're going to substitute them into our equation of the line and solve for b. All right, 1/2 times 3 is 3/2. If we subtract 3/2, we're going to get b is equal to negative 5/2. All right, so b is negative 5/2. We already said that the slope was 1/2 because in parallel lines, the slope is the same. So the new equation for my line is y equals 1/2 x minus 5/2. That's using the new slope as well as the b. That is the new equation of the line. All right, the next example, find the equation of the line that is parallel to the line 3y minus x equals 5 and passes through the point 3, 3. Again, we're finding parallel lines, which means the line has the same slope. We're finding the equation for the new line. Go ahead and try to do this one. It's just like the previous example that we did. Give it a shot, and we will check it when we come back into class.